In this video, we will discuss basic terminology relating to angles. An angle is made up of two rays with a common endpoint that we call the vertex. Each angle has an initial side and a terminal side. The angle is formed by rotation about this vertex. The rotation starts at the initial side and ends at the terminal side. If it's a positive angle, that is when we go in a counterclockwise direction. A negative angle is formed by starting at the initial side and stopping at the terminal side, but going in a clockwise rotation. The most common unit for measuring angles is the degree. A complete rotation of a ray gives an angle of 360 degrees. So we can start here and describe our rotation, and if we stop here, that would be 360 degrees. Notice that it appears that the initial side and the terminal side are exactly the same line. If we had a vertex and a ray, and there's no indicated rotation, then that would be an angle of 0 degrees. An acute angle is any angle between 0 and 90 degrees. So when we look here, this will be a 0 degree angle. And our acute angles would be anything in between 0 and 90 degrees. If I point straight up, that would be a 90 degree angle. So our acute angles live anywhere between 0 and 90 degrees. An obtuse angle would be between 90 degrees and 180 degrees. And a straight angle would be 180 degrees, and that's because it forms what it looks like a straight line. A 90 degree angle, we would describe that as a right angle. That would be a quarter rotation about the circle. Complementary angles are when we add two positive angles that add up to be 90 degrees. And supplementary angles will be when two positive angle measures add up to be 180 degrees. Those angles will be called supplementary. Standard position is when we orient our angle to have the origin as our vertex, and the initial side would lay on the positive x-axis. When we describe a quadrant 1 angle, we're talking about the terminal side lays in quadrant 1. There are two different ways that we could get to quadrant 1. We could go in the positive rotation direction or in the negative rotation direction. But the angle is described by the quadrant in which its terminal side lies. A quadrant 2 angle in standard position, we would rotate until our terminal side lays in quadrant 2. A quadrant 3 angle in standard position, we would rotate until our angle puts its terminal side in quadrant 3. That would be a negative angle because we went in the negative direction. And a quadrant 4 angle in standard position, we can rotate more than 360 degrees. So here I'm going to put my initial side here on the positive x-axis, and I went a rotation of 360 degrees. I can also go more than that, as many times as I want to go around to change my angle measure. So this will be 1, 2, it looks like 3 rotations and a little bit more. But that would be a quadrant 4 angle. Quadrantal angles are angles whose terminal side doesn't lay in a quadrant but lays on an axis. So 0 degrees would be a quadrantal angle. 90 degrees would be a quadrantal angle. 180 degrees would be a quadrantal angle. We can also go in the negative direction to find a quadrantal angle. So if I go in the negative direction a quarter turn, the terminal side would lay right there on that negative y-axis, but since I went in the negative direction a quarter turn, that would be described as negative 90 degrees. Notice that if my initial side laid on the positive x-axis and I went in the positive direction to stop at that same exact terminal side, that same initial and terminal side could also be described as 270 degrees. These two angles have exactly the same initial side, exactly the same terminal side. The only thing that makes them different is the amount of rotation and the direction of the rotation. Okay, so 0 degrees there. We could form another quadrantal angle by doing a half rotation in the negative direction. That would be negative 180 degrees. We could also form a quadrantal angle by going around the circle more than once. So let's go around once. Of course, that would be 360 degrees. But let's say that we don't stop there and we continue our rotation to include 2 rotations. So I'll go around one more time. If I go around twice, that would be 2 complete rotations, so that would be 720 degrees.